Hi, I'm Ben Stöchen from California State Polytechnic University in Pomona, California. And today I'm going to talk about our ongoing work on multilingual information interaction and retrieval. Now, at this stage, I typically ask the audience whether you are bilingual or multilingual. And to keep things interactive today, how about you write into the chat how many languages that you are proficient in? Now, I'm not going to be surprised if there's lots of numbers that are higher than one, because more than half of the world's population is actually bilingual. In some areas, such as the European Union, numbers as high as 96% of people are learning foreign languages and making all of these people multilingual. The same goes for here in California. More than 44% of people in California speak a language other than English at home, while also being proficient in English at the same time. And of course, this is a worldwide trend. And here's a fun ad from a couple of years ago that was hanging all over airports, where it said 5 times more people are learning English in China than there are people in England. The world belongs to those who see its potential. And that's the area that we are working in. We are trying to support multilingual people with our work. So what's the current paradigm of multilingual information access? Well, the most common thing is localization, which basically means translating one system into another language, porting from one market into another market. So that is supporting multiple languages, but not necessarily supporting multilinguals. So in our prior work, we have looked at truly multilingual systems. So for example, what we've looked at in the past is multilingual user interfaces. So what if we try to present multiple languages in one search result interface? So we looked at all different kinds of interfaces, which one works best for what kinds of people. And one of the most striking things was that a user's proficiency had a big impact on what kind of user interfaces worked best. Another thing that we looked at was, what if we give users the options between monolingual lists and multilingual lists, or query recommendations in their first language or their second language? We again found that multilingual people like multilingual systems. So here's an example where we saw that if a person's proficiency was quite high, people actually preferred the multilingual lists quite overwhelmingly over monolingual lists. But again, this was strongly dependent on a user's proficiency. And then similar or related to this, we also try to predict what kind of language or what kind of result list people would prefer. So again, proficiency showed up as one of the most important features in these predictions. So that's where we are today then. Our research question is, well, what is the extent to which a user's language proficiency can be inferred from their behavior while they are evaluating search results? Because knowing a user's language proficiency, we can then adapt our search system to that proficiency in terms of the interface, in terms of the results that we provide, and so on. Now, in our work, we specifically looked at inferring a user's language proficiency from their eye gaze behavior. And to do that, we ran a study with 32 participants, 27 of which we could keep the data from. 19 of them were multilingual English-Spanish speakers, 8 of them were English-Chinese speakers. And what we had them do was we had them fill out a consent form, then 2 self-rated proficiency questionnaires, commonly used in literature, ILR and CEFR, then 1 proficiency test per language, which is basically an objective proficiency test. Then we calibrated our eye tracker, including pupil baseline. And then what participants had to do was perform 30 simple search result page relevance judgment tasks. So here would be an example. What participants had to do: they were shown a description and they were shown a query. And then all participants had to do was to just evaluate whether they thought the different results were relevant to that query or not. Then we took participants' eye gaze data and we processed it into a series of features. So we took the raw eye gaze data in terms of people's fixations in the saccades, which are the distances between different fixations, and we calculated a number of features from that. For example, what is the average fixation duration, and what is the average saccade length, and what is the standard deviation of the saccade length, and so on. In addition, we also looked at specific areas of interest on our search engine result page. Specifically, we looked at individual results as individual areas of interest. So we fed all of that eye gaze information into a classifier, and specifically we looked at regression and tree-based classifiers. And what we tried to do was, well, can we classify users' proficiencies, i.e. can we infer a user's proficiency just based on those eye gaze features? So we tried to infer both the questionnaire proficiencies and also the objective test proficiencies. We also had different types of feature sets, and the details of that would be in the paper. So the results for that was that if we are just using individual AOIs, so what that means is that after having just seen a single result, we could already make some inferences about a user's proficiency. So after a user has only gone through a single result, we can already make some inferences about the user, and we would beat a baseline by a statistically significant margin. Now, if we had information about the user's full interaction with an entire search engine result page, our results got a lot better, and you can see we would get up to 80% or even up to 90% of accuracy in terms of inferring what a user's proficiency was. Now, this is on a binary split. We also looked at a three-way classification where we split participants into low proficiency, medium proficiency, and high proficiency. And again, for all of the languages that we used, the results were actually all statistically significant. We also looked at what are the most important features, and we found that specifically average fixation duration had a big effect, and also refixation ratio, which basically means users backtracking, having to read again or go through a search result again, had a big impact on the prediction accuracy. Okay, to finish up, we showed that inferences of user language proficiencies can be feasible, and that certain features were more important than others. Lastly, what we want to do in future work is to extend our experiments with a more nuanced view of user proficiency. For example, some domain proficiency may be different from general proficiency. We also want to have setups that involve simulated work tasks. And we also want to have setups that use standard camera technology as opposed to the research grade eye trackers that we used for this work. Thank you very much for listening to my talk, and I'm looking forward to any questions that you may have.